For these questions where you're going to use the integrating factor method to solve your DEs, you need to ensure that the equations you have are in the form dy dx minus some function of x, y, equal another function of x. So dy dx minus or plus, let me use plus, it's easier to work with. P of x, y is equal to q of x. It must be in that form to start with. For our first example, it is in the form. Here we have our dy dx plus we have some function multiplying y, and we just want to ensure that this function that is multiplying y does not contain another y in it, right? So it can be a constant or something in terms of x, is equal to some function of x, and it could also be a constant over here. Having it in that form, we can proceed to find the integrating factor. And remember, the integrating factor is found as e to the integration of p of x dx. Your p of x here represents the function that is multiplying y. What is the coefficient of y? In this case, the coefficient is 2. So this is equal to e to the integration of 2 with respect to x. And we know when we integrate 2, we get 2x. And so that is our integrating factor, e to the 2x. We're going to take that now and we're going to multiply the equation. So I'm going to have e to the 2x dy dx plus 2e to the 2x y, as I took it and I multiplied it here, is equal to e to the 2x times e to the negative x. Now, what you have on the left is actually the product rule of, and it always works this way, d dx of y times the integrating factor. That is what is on the left, right? And you can check it. If you had this to integrate, this product here, you would keep the second, differentiate the first, plus keep the first times differentiate the second. So that's exactly what we have here. So on the left, we're going to rewrite this thing here as the derivative, or the d dx, of y times e to the 2x. On the right, I'm just going to simplify using indices rules, and we get e to the x. Good. The left side now is going to be integrated, and so will the right side, but this time with respect to x. So when you integrate a derivative, remember they're reverse processes, so we get rid of the derivative and we end up with y e to the 2x is equal to, integrate the right side now, e to the x plus c. And what I did over here, changing this to a derivative and then integrating, in subsequent questions I'll skip these two steps. I'm going to jump straight to y times the integrating factor, because it always works out that way on the left. All right, so now we have y e to the 2x equals e to the x plus c, and we can go ahead and solve for y by dividing through by the e to the 2x. And we can leave it there, or if you want to simplify it, you can. All right, and that would be the solution, the general solution for the differential equation we started with. Let's look at example B. Second example, this was A. All right, now the difference with this one is we are given 2 dy dx, because that's what the y prime stands for. So 2 dy dx minus 4y is equal to 1, which is not in the form that we need it. We need to have it in the form dy dx plus something multiplying the y equals something else. What we need to do, therefore, is to divide through by the 2, because the problem with this one, why it looks different from this, is the 2 that is the coefficient of the dy dx. The coefficient should always be 1. So we're going to divide through by 2. And now I have what I need in the form that I want. Right? It's perfect. So I'm going to go ahead and find the integrating factor, which is equal to, again, e to the integration of the p of x, or the coefficient of the y, which in this case is -2. So -2 dx. Integrate, we get -2x. And so our integrating factor is e to the -2x. Now, as I said, we're going to take the e to the -2x and multiply the entire equation and then do some manipulation to the left side. But the left side will always work out to be y times the integrating factor, right? So I'll skip a step or two. So let me go ahead and multiply through by e to the -2x. And then, as I said, the left side will become y times the integrating factor, so y times e to the -2x. And the right side we will have to integrate. So we get half e to the -2x divided by -2. And do not forget your plus c. It's very, 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 very important, especially when we're doing differential equations. And then I'm going to go ahead and make y the subject by dividing through by e to the -2x. And if I divide this by e to the -2x, the e to the -2x will move to the top and the sign changes, so ce to the 2x. And that's your answer for B.